So from the last session, we are saying the last statement says the functional group is a specific group of atoms within the molecule that is responsible for chemical characteristic reaction. Just like human beings have certain features within themselves that are common in specific families. I was saying, we find it in the video, you'll find that certain families, they are light, maybe they have a soft skin, and that is the identity in that family. You find that maybe they stammer, maybe they have a unique way on how they talk. That is what is common in that family. So, just to take you through, we are saying that the classification, the putting together of these thousands of groups or these thousands of compounds being put together, we realize that, or we have to realize that the members of such groups, I'm connecting. We have organic compounds that are a lot. Now we can't study them at the same time. We have to put them in groups. Now, within a particular group, when you pick a particular group, what are you likely to find? We are saying, A, within that family of members, we expect the members to react in a similar way because, like I spoke about human beings, they have something common in them. Because they have something common in them, we expect them to react in a similar way. And I was also saying that certain families put up rules, and these rules should be followed. So the rules that must be followed by members within the homologous series is what is called the general formula. I'll come and explain the importance of the general formula. Now, also, if you belong to a Mushinge family, every member of that family has to have or needs to have the ending of their names must be the same so that we are able to tell that these belong to the same family. If it's a Lungu family, there's Messi, it's Messi Lungu. There's Jacqueline, there'll be Jacqueline Lungu. There's Matilda, there'll be Matilda Lungu. So the ending of the members in that family must be the same. And that's what D is actually talking about. I'm just connecting. Now, we're saying that because they have something common in them, which make them react the same, which make them have the same ending, that thing they have in common is what is called the functional groups. So each family has got a unique functional group that we can use to identify it with. You find that if it's a group of people in this family, they have sharp pointed nose, or maybe they have maybe they are similar in the way they appear. So that unique part of the molecule that we can use to identify any other compound that we can put in the same group is what we are calling the functional group. Now, by definition, we're saying a functional group is that something which is added to a molecule, which we are calling a substituent. Something added to a molecule is a substituent. Now that substituent is could be an atom, just an atom added to a molecule, or maybe a group of atoms that are added to the molecule, or maybe a moiety. A moiety is just a bond, or it could be that there's a particular bond that is present within that molecule. And the presence of that bond, it makes the compounds to react in a similar way. That is what we are calling a functional group. So starting from there, we need to look at examples of homologous series. Now, the way I was teaching the grade 12 B's is different from the approach that I'm going to use to introduce this to you. I am not going to mention all the homologous series at the same time. No, I'll pick one. We talk about it. Once we exhaust much of the information, then we go to the other one. So the first homologous series that we are going to look at is called alkane. So Mercy, we have actually started talking about what you said as the things that confuse you. Okay?
Okay.
So an alkane is a first homologous series that we're going to look at. Now within this alkane, from the name itself, from the name alkane, there are two things. There's ALK. This ALK, we are actually calling it the prefix. We're calling it the prefix. And the ANE, we are actually calling it the suffix. Now, these things that have included, the prefix and the suffix, they all have the meaning. The names of these compounds, we don't just name them anyhow. Or this homologous series was not just given a name anyhow. Actually, they have specific meanings. And right from the beginning, you need to know what these actually mean. Right from the beginning, you need to know their meanings. Right from the beginning.
So
Yes.
I'm sorry. I just received a phone call from a strange one of my friends that I was with at tuition. I don't know. She's called me. She's crying. I don't know if she's stolen her phone. Can I just call you back? That they've stolen her phone.
Oh.
Can I just join back?
Okay.
Okay.
Yeah. So Mercy, we can continue. I was saying the first homologous series that we're going to look at is alkane. Now, the word alkane has got two things attached together. The first one is ALK, which I'm calling the prefix. The ANE, I'm calling it the suffix. Now, each of these mean something. Okay. Now, from the word ALK, what does it mean? So ALK means, it is telling us ALK that the parent or the compound itself is made up of hydrogen atoms and carbon atoms. So ALK is telling us about the relationship which is there between the number of carbon atoms and the number of hydrogen atoms. Maybe I should say ALK is telling us more about the number of carbon atoms. The ALK. Meaning if the number of carbon atoms are 3, the ALK will tell us how the name will actually start. Let me say it again. The ALK from an alkane is telling us more about the number of carbon atoms. Now, for as long as you know the number of carbon atoms, it is very possible to know even the number of hydrogen atoms that will be there, because there is a relationship that we have from the general formula. That's the ALK.
Okay.
Then the ANE is actually telling us more about the type of bonds holding carbon atoms together in the molecule. I'm saying the ANE is telling us more about the type of the bond. Could be the double bond, could be the triple bond, could be the whatever type of a bond that it is. But because we have used the ALK, the type of a bond is carbon to carbon single bonds.
Okay.
That's the meaning of ALK. That's the meaning of, that's the meaning of ANE. ANE is telling us that all the carbon atoms within the molecules that are found within the family of alkanes should be joined by a single bond throughout. I want you to ask questions if you are not understanding from the beginning.
All right, sir.
You okay?
Yes.
Therefore, from here, how can we know the number of carbon atoms and its relationship to the ALK? How can we tell the relationship between the number of carbon atoms as well as the ALK? So with me here, I'm gonna have a table. Within this table, I want us to have the table which will connect the number of carbon atoms as well as yeah, can we continue to discuss later? We have the number of carbon atoms, This is coming from the ALK. I want you to understand. The number of carbon atoms, remember the alkanes started with the ALK as a name, meaning the number of carbon atoms that will be present in that member of the alkane, its name will actually come from the number of carbon atoms. That's what it means.
Wait, sir, please repeat.
Okay, I'm saying the name of this homologous series we are dealing with is alkane. And because it started with ALK, meaning all the members that will be found in this homologous series should start with the ALK. All of them, the names should start with ALK, right? Now, this ALK that each member will start with, the ALK will be represented by the number of carbon atoms that are present in that molecule. So we can have the number of carbon atoms as 1. We can have the number of carbon atoms as 2. We can have 3. We can have 4. We can have 5. We can have 6. We can have 7. We can have 8. We can have 9. We can have 10. But for the sake of the syllabus that we have, we might just end with 10. Now, if the ALK, which is representing the prefix, the ALK is actually representing the prefix. the number of carbon atoms. Therefore, how is the ALK with one carbon atom going to be called? It will be called meth. You get a point?
Yes.
It's an alkane. Now, because this alkane has got one carbon atom, so the ALK will be represented by the prefix meth. That's what we are saying. Now, what is the suffix?
N.
The suffix is A-N-E. The suffix is A-N-E. The suffix is for all of them, by the way.
Sir, can I wait? My network is a bit bad. Let me try leaving and come back again. It's
Okay.
breaking a bit.
Oh, right. Yeah. So what I'm saying, the suffix will be the same for all of them. All of them. All of them. The suffix will just be the same. And actually, the suffix is A-N-E. For all of them, actually. Therefore, if we have the prefix and we have the suffix, what will be the complete name of that compound? I'll give you an example. What we are talking about is this. Let's say you belong to a Lung family. I'm just giving an example. You belong to a Lung family, and within that Lung family, all of you should be having the names that are ending with a suffix, which is Lungu, 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 in regardless of who you are, right? Meaning if the firstborn is John, the complete name should be John Lungu, right?
Yes.
Yeah. If the second-born is Mark, the ending will still be the same. It's Lungu, it's John Lungu, Mark Lungu, all together. So that's what happens here. So the starting, which is the ALK, will be represented by the number of carbon atoms. And if the number of carbon atoms is 1, it's it's meth. And if there are 2, it's going to be eth. What about 3?
I think it's
Prop.
pentane.
Prop.
Oh.
I'm just talking about the prefix. If there are 4, we don't but we call it but. If there are 5, we actually call it pent, the pent that you have said. That's why a pentagon has got 5 sides.
Hello, sir.
Yes, Miambo.
You can get me?
Sure.
All right. I think now it's better.
6 is called hex. 7 called hept. 8 oct. That's why we have got octagon. 9 is non. We have the nonagon. 10, not deck. It's not December, but deck, like that. So this is how the number of carbon atoms present in the member of a particular homologous series are actually represented by the prefixes. I don't know if it's making sense now.
Yes.
So now, having known this, the name, what will be the name of those very compounds? So the names are actually just a combination of prefix plus suffix.
Perfect.
So now you guys can do the magic, right? So let's complete them. What will be the first name?
Methane.
Exactly. Meth and then ANE.
Yeah.
Exactly. So in short, we're just gonna get what is here, meth. We put it here. We also add what is there. We put it there. We have the name, methane. So methane, when you
Yeah.
go on the internet, methane, you will realize that it is an hydrocarbon or it is an alkane compound that has only one carbon atom. It's because of the meth. What would be the second one?
Ethane.
How do we spell it?
ETHANE.
Exactly. So it's very simple. And you guys can complete. Allow me to just do maybe 7. I'm going to put it here. And this, which doesn't change, I'm going to put it here. And we have the compound. But for now, we only know the number of carbon atoms. We don't know the number of hydrogen atoms. By the way, alkanes are hydrocarbons. Maybe before I even go to, okay, I'll put up some more information down here. So, can you all guys complete? Give yourselves tasks. So the first 3 is for Mercy. The last 3 are for Miambo.
So. Sure.
You guys have shown you what to do. Mercy, your first 3, Miambo, the last 3.
Let me look for my chemistry book. Sure.
No need for that. The information is already. You're actually not even thinking. You're just getting the vibe.
Eso es stupid.
No. You are just saying them.
Okay, so the third one is propane,
Okay.
4th butane, and then it's pentane.
Okay. So all of them are ending with ANE, right?
Yes.
Yeah.
And that's what I actually said.
It's the same with the last 3, sir.
Wait,
Octane.
you are actually leading us.
So this is something you're posting on YouTube. So mispronouncing the name.
We are not here to teach English on how to do the sound thing. We are doing chemistry.
So
That is
it's
the
my one on YouTube.
that-
On YouTube, it's my one.
That is the
Please.
mentality that will actually lead you to maybe not do the right thing. We are not here to teach English. The best that you can do, give us the spellings. We'll write them. We are learning.
Okay. So then I'll just give you the spellings.
Please.
It's fair.
Mm-hmm.
So for this 7th one.
No,
Okay, ready for the sentence. For the 8th one, it's octane, which is OCT, then ANE at the end.
Okay, so OCT. Like that?
Yeah.
Mm-hmm. 9th
Then for the 9th one, it's NON. From what I researched, there was YNE. That's what I saw from what I researched when I was studying in the morning.
There was?
I don't know. When I was studying in the morning from the research that I did, it was NONYNE.
Just a minute. It was
NON
O N
Y
Y
YNE.
YNE. No, 9.
Yeah, that's no 9. Yeah.
Okay, so you have to understand that chemistry is very wide. Have you seen how it has ended? Have you seen how it ended? So the ending part of a molecule is very important. For as long as we are dealing with the alkanes, I would advise that let your ending be like what we have actually talked about. Because the ending of YNE, it is actually representing that there are 3 double bonds. or that there are 3 bonds within the molecule, because the ending is different. This is from a different family, not the family we are dealing with.
Okay.
Let me just give you an example of this one. If we say ethine like this, the ending is different. If it is ethane, it's supposed to be carbon, single bond, carbon, because it ended with ANE. Now, when you say YNE, it means it's supposed to have 3 bonds. So don't change the family. We have not yet gone to that family.
So, it should just remain the way it is
The
with
way it is,
ANAD.
that is the way it's supposed to be, because we are dealing with one family. We haven't gone to the other family. Of course, there are such compounds, but they don't belong to this family.
Okay.
Because what we said is that all the members within the group supposed to end in the similar way. So if you see that this molecule is ending differently, just know that you are dealing with a different member. It's like you are given books. Those books supposed to have Pestalozzi written on them because we belong to a Pestalozzi family. And then you find that something else is written on that book. You know it doesn't belong to Pestalozzi. Yeah. So please note that members of the alkane family,
So I haven't completed the word note.
please note that the members within the alkane family have the following. 1, these members should obey the general formula. Like we said, should obey the general formula. And the general formula for the members, all of them, it is C with a subscript N. This N is representing the what? The number of carbon atoms. Then, because this compound contains only hydrogen and carbon, therefore, having known the number of carbon atoms, we should be able to find even the number of hydrogen atoms. So what is the relationship? The relationship is, if we know the number of carbon atoms, represented by N, to find the number of hydrogen atom, get that very N, multiply by 2, then add the 2 at the end, then you know the number of hydrogen atoms. I'll say it again.
Sorry, repeat.
I'll say it again. Members of the alkane formulas, they have carbon to carbon single bonds. I'll come back to that. Thirdly, they have atoms of carbon and hydrogen only. That's a point I want now to write on. They have only carbon and hydrogen. So if you know the number of carbon atoms, you should be able to know the number of hydrogen atoms. How do you do it? We use the general formula. And we are saying, if you know the number of carbon atoms, to find the number of hydrogen atoms, use this general formula. The same N which is here is the same N which is there. So if the number of carbon atoms is 8, how many of hydrogen atoms will they be? There will actually be 18. What do I mean? We are going to say, see, the number of carbon atoms is 8, But for H, we are going to say 2. We multiply by the same number of carbon atoms. And then at the end of the day, we're going to add only 2. And therefore, how many are they going to be? Carbon, there will be 8, and hydrogen will be, what is 8 times 2?
18.
That's
16, right?
8 times 2,
Yes.
16.
Yes.
Then plus 2, it's 18. Meaning, this is the combination of hydrogen and the carbon atoms in this compound that has got 8 carbon atoms. So octane is supposed to have the molecular formula of this nature. By using the general formula, so the general formula is actually very, very, very important. Yeah. The other one that I have to write is that the members of the same family have, we are coming to prove this point, have consecutive members differing by a CH2 unit. We will come and prove this point. Consecutive members have the differences of CH2 unit only. CH2 unit only. So the task that I'm going to give you guys.
Yeah.
Now, because they only have carbon and carbon hydrogen, carbon to carbon bonds, they are said to be very saturated, very unreactive. These compounds are very unreactive because all the bonds present in them are fully occupied. So they don't have anywhere else where any other compound can sit unless one hydrogen is removed. I will come and explain on that.
Okay.
But for now, as we go into the last session, before you join, I'm giving you 2 minutes. Within these 2 minutes, I want you to complete this table. This table will have the number of carbon atoms. Carbon atoms.
Are you going to send that to us or we copy it?
I will send, you can still copy.
Okay, it's better maybe you should send it.
Number of hydrogen atoms. Molecular formula. I want you to complete this information. So you are going to have the number of carbon atoms. This is the N. The number of carbon atoms, 1, 2, 3, 4, 5, 6. This is what we have. And how many